class 12 students. Welcome to Maths Possible. Today I am going to start the next part of your video. And in the last part I had done till question number 9 most probably. Okay. And today I am going to start with determinants chapter question number 10. Okay. So those of you who have the book. So this is the question. It says, without expanding, prove that. Without expanding, you have to prove this. So question number 10. Without expanding. Without expanding, we have to prove that the determinant A, B, C, X, Y, Z, P, Q, R is equal to X, Y, Z, P, Q, R, small q, P, Q, R and A, B, C is also equal to Y, B, Q, Y, B, Q, X, A, P and Z, C, R. Okay. So look at it very carefully. We are going to use one of the properties to prove this is equal to this and this is equal to this and also this is equal to this. Okay, so let us start doing it. Alright, so let's start proving this one is equal to this one. Let's give them 1 and 2 and this is 3. Let's start proving 1 is equal to 2. So we are trying to prove 1 is equal to 2. Okay, you don't have to start writing this. Okay, we are going to prove, then we are going to write it that 1 is equal to 2. So let's start the proof. Okay, so proof. So let's take the main determinant. Let's name it determinant number 1, and that is A, B, C, that is X, Y, Z, and that is P, Q, R. Okay, so basically let's name these like this is determinant number 1, this is the second determinant, so that way it's better, and this is delta 3, determinant number 3. So let's start doing it. So by property, where it says that when you change one row or column, then the determinant changes by a negative sign. So you can see, if you look at determinant number 2 very carefully, the A, B, C over here that was in the first row has now gone to the last row. Okay, so let's do that first. Okay, so let's put this first row elements in the last row. So if I make this and if I write let determinant 1 dash equal to negative, okay, then I put the PQR on top and replace the PQR with ABC. You see, I have replaced the PQR with ABC. Okay, so I put the ABC down and take the PQR up. Put this up and take this down. Okay, now what do I, the middle one is the same, X, Y, Z. Okay, so I got a negative 1 dash. Okay, now I have a problem is because I still haven't got this. Okay, I still haven't got my determinant 2 because my X, Y, Z now has to take the first row and my PQR has to come down. So let's do that. So let this be equal to, so I have to make this I'm rubbing off this. Okay, let's do it nicely. Again write let determinant 1 double dash is equal to negative whole thing, negative, negative, positive. Okay, again it's going to change. This is going to go up, okay, and this is going to come down. So x, y, z went on top, p, q, r is here, and a, b, c is here. So which is equal to my determinant number 2. So 1 is equal to 2, right? Look at it very carefully. The determinant 1 dash is equal to 1 double dash is equal to 1 dash, and the determinant 1 dash is equal to determinant number 1. Okay, just change. So you can see they are equal. Okay, so now you can write determinant 1 is equal to determinant 2, because when you are changing it, it is becoming this, then again when you are changing it, it is becoming this. This is changing. Okay, students, understand it. So this is my first part, and I have proved it that determinant 1 is equal to determinant 2. Now let's look at my determinant number 3. Now let's look at the pattern. We have to understand the pattern, how it's changing from here to there. Okay, you will notice that the x, y, z is now in the column. First it was in the row, now it's in the column. Let's rub this off. Let's rub this off. I am trying to prove that determinant number 1 is now equal to determinant number 3. Okay, so let's prove that. So this proof is over. First one I have proved. Let's prove my second one. Okay, so I'm trying to prove this is equal to this. So if you notice very carefully, this one and this one and this one, notice only. Okay, you will see that this xyz has now gone into the column. Yeah, okay, so don't we have a proof that says that interchanging rows or column of a determinant does not change the determinant, isn't it? There is a property saying that. So you can check out that the property where I have already proved in part 6 or part 5 maybe in the determinant chapter, Aggarwal book. So let's start writing. So now the determinant 1, which is equal to a, b, c, x, y, z, p, q, r has now changed to determinant 1. Then don't write it here. Let's change it in some way. Now determinant 1 dash will become, okay, will become a, b, c, x, y, z and p, q, r. You see that, which is actually equal to determinant 1. Even in the earlier ones you make these equal to determinant 1. Again the double dash will be equal to determinant 1. I have forgotten to do that. You do that, okay, so that you know that they are all equal. So this is equal to that. Okay, doesn't change, nothing changes. Alright, now look very carefully, very carefully. Now with this we have to work with this. Okay, we're done with this. We have to work with this. Now where is my x? My x is here in the middle and my y is up. See, but they are in the first column. So let's change that now. Let's change that. So you have to write determinant 1 double dash will be equal to, now I am changing it, is equal to negative. Okay, we have x, y, z in the first column, x, y, z. Okay, a, b, c in the second column, so I am getting it correctly only, and p, q, r in the third column. So look at it, look at this, the x, y, z went from the second to the first column. So basically this is equal to determinant 1 again, okay, with a negative sign. Alright, now look very carefully. Now what I have to do, I have to make this, right, determinant 3. So let's change this. Now I have my x in the middle, but my x is up on top here. So let's change that again. So the next one, determinant 1 triple dash, will be equal to, so negatives positive it becomes because the row is changing. Okay, so I have a y on top, then I have b, then I have q, yes, correct, then x, a, p, and the down one is the same. Okay, which is equal to determinant number 3. So now what we have proved? Now we have proved that this determinant 1 is equals to the determinant number 3. Okay, understood? So because this is equal to the determinant 1 and the determinant 1 is equal to determinant, this whole thing is equal to determinant 1. Okay, you can write over here also delta 1. Okay, you can write like this. First delta 1, which is equal to delta 3, because delta 3 is that. Okay, so they are both coming same. So 1 to delta 3 I have proved. In the next, I am going to prove this to that. So check it out. I think all of you can prove this. Now determinant 2 equal to determinant 3 I have tried to prove. Okay, so you see in class 12 there are 3-way proving. Because there are 3 things, so there has to be a 3-way proof. 1 is equal to 2, 2 is equal to 3, also 1 is equal to 3. Okay, so that way. So I have proved the easy one first, then the difficult one. The first one is 1 is equal to 2, then I proved 1 is equal to 3. Now I am going to prove 2 is equal to 3. So take 2. So the determinant 2 is given as x, y, z, p, q, r and a, b, c. So this determinant can be written, so you see x, y, z is in the column. So this determinant can be written x, y, z here. This is p, q, r over here and a, b, c over here. Okay. So that way I got x, p, r, x over here. Now I can just change. Okay. From here only you can change if you want. Alright. So let's see what is changing. My x is coming down, y is going up, but still I have a problem. So let's change this there, because you see my p and q is coming in the 3rd column, okay, and my a, b, c is in the 2nd column. So I can write it, you can write like this, okay. So this is equal to negative, okay, that will be x, y, z here, a, b, c here and p, q, r over here. So this is a faster way of doing. Okay, now what do? Now simple, you just take this y, b, q up there and bring this down. So then it becomes a positive. So then that will be equal to, I am writing it here, that will be equal to, so this goes up, y, b, q and x, a, p and z, c, r. Alright, so that's delta 3. That's delta 3 equal to delta 3, right? No space. So delta 1 is equal, delta 2 is equal to delta 3. There you go. All proved. Okay. So let's do one more question. Okay. Then it's time for my class actually, and I gotta go. So let's do one more question and let's leave it for today. And we'll make another one. Long video. We'll make. So let's do part 2 of this. 10 part 2. Okay. Let's do this question and finish it off. So expand without, prove without expanding. Prove that a, b, c, okay, a square, b square, c square and bc, ac, ab, bc, ac, ab is equal to, what is that, 1 1 1 1 1 1 a square, b square, c square and a cube, b cube, c cube, a cube, b cube, c cube. Fairly easy sum, very easy question actually. So start with the LHS, so determinant LHS. So let determinant 1, don't have to write determinant 1, just start with LHS. Okay, so this will be A, B, C. This is A square, B square, C square, sorry, BC, AC, AB. So what you do is you multiply A with the first row, B with the second row, and C with the third row. So you do this. You do this. 1 by ABC. Okay, that will be. So you're multiplying actually ABC. So you have to take ABC as 1 by, so that it becomes the same thing. Okay, so you have A square, A cube, ABC. So you multiplied A with the first one. So this became A square, this became A cube, this became ABC. So this is going to become B square, this is going to become B cube, this again ABC. Again from here this is C square, this is C cube, this is ABC. So can you see? Very easy actually. Now you take out ABC common from the first column. Okay, so what do? You write ABC, divide by ABC. So that came out common from the first column. Then what do you have? You have A square, B square, C square. Okay, A cube, B cube, C cube, 1, 1, 1. So you see it's coming something like that. Okay, but still hasn't come because we have to interchange now. You cut this out, ABC, ABC. Let's do it on top there. Okay, so now what do? Now you interchange. So what was I supposed to prove? I was supposed to prove 1, 1, 1. Then A square, B square, C square, A square, B square, C square, A cube, B cube, and C cube. This is what I am supposed to prove. So actually it's done. Bring this here and take this there, then you take this that side. So which is equal to, so it becomes positive, which is equal to, like this, it will become 1, 1, 1. First negative 1. Then this becomes A square, this is A cube only. A cube, B cube, C cube. This is A square, B square, C square. Okay. Next one. Now the cube has to come this side, so this becomes a positive. Okay. That becomes 1, 1, 1. This is A square, B square, C square, and this is A cube, B cube, C cube. That is proved. So you can write proved over here in your copy and then finish it off. That's it. That is what I had to prove. I have proved it. That's the proof. Okay. So that's it, students, for today. We will continue in the next video, and I will make the next video long for you, I promise. Okay, so take as much help as possible from math as possible. See you in the next video. Bye bye.